Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 43 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice big mug of iced coffee. And today I will also be enjoying some hot coffee. And I need you to get ready to learn some cool new stuff. Okay, let's go ahead and get out our Jetson Nano gear. As we're getting out our gear, as always, I want to thank you guys who are helping me out over at Patreon. Your support keeps these great lessons coming. You guys who are not helping out yet, look down in the description below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's learn something new today. Okay, now where did we leave off in lesson number 42? In lesson number 42, we had gotten to the point that we could recognize, we could identify faces coming off of live video, and that was really pretty cool if you ask me. So what we're going to do today is we are going to kind of push that a little bit further. If you noticed in last week's lesson where we're doing the live face the face recognition and face identification on live video, we finally got to the point that we were sort of maxing out some of the capabilities of the Jetson Nano and its 128 core GPU processors, okay? And so we had to sort of start trimming things back to get it to operate quickly. So you can see that we can reach the point where we have a trade-off between some of the parameters of artificial intelligence and identification and then how fast it will run. So if we're going to make those trade-offs in a good way, we need to be able to instrument our code, and instrumenting our code will allow us then to kind of more quantitatively make those trade-offs where we can have it be as snappy as possible, but at the same time accomplish what we want with the facial recognition. So we're going to learn how to instrument our code today. So let's go ahead and let's open up our Visual Studio Code to a fresh new window. And now with that done, what we are going to do is we are going to come into our PyPro folder. And then I do believe I was working inside of Face Recognizer. And then inside of Face Recognizer, we're going to create a new file. And that new file, I do believe, is going to be Face Recognize. And then this was going to be like video or program number 6. And then let's call this live FPS for frames per second. Because as we move forward, .py, don't forget the .py. As we move forward, what's going to become really important is this concept of frames per second. And we need to not just look at it and qualitatively see how jerky it is, but we need to kind of have a number. What is our frames per second? And then we'll be using this instrumentation on future lessons as we move forward. So we're going to start where we left off in the last lesson. So I will need you to I will need to get out of your way. And then I will need you to go to the most excellent www.toptechboy.com and then look up AI on the Jetson Nano lesson 42. That was last week's lesson. Come down and let's grab that code, okay, with that little button, and then right mouse click copy. We will come over here. If you already have your code, you can just use that. But if you need to catch up with where we were before, that is how you do it. Now, I think it would be a good idea just to make sure this works and that we haven't broken something. So let's right mouse click and let's run Python file in terminal. Takes a second so we can enjoy a little coffee while we wait for the face recognizer library to load. Okay, looks like it is loading. We always get that GStreamer error. I'm really trying to figure out how to get rid of that error, but I haven't figured out how to get rid of it yet. It just doesn't seem to hurt anything, but it bugs me when we have such errors. And it seems like it is an awkwardly slow process today. Let me get this a little bit better up here. Okay. And hopefully we will have a window jump up shortly. It will give you guys kind of a chance to get your stuff all settled in here while we're waiting on this to run. Do we have an error here or something? Let me see. Do not seem to have any errors. Okay, there it looks like it's going to come up. Boom! Look at that, recognizing Paul McWhorter. Okay, we got that. So, well, it's not a huge accomplishment. We had it working last week, but sometimes it is encouraging when we come in and things are working. Now, you can see that there is a little lag in the video. There is a little latency, and there's a little choppiness, and that's what we want to go in and try to understand better. So we are going to quit out of that. I am going to be mindful to adjust my window where you can see things very nicely. Okay, let me bring this up. A more organized person would have had this already in place before the video started, but you guys don't come here to see an organized person. You guys come here to watch me crash and burn, right? It's sort of like NASCAR. People just go for the wrecks. You just come to watch me crash and burn, sometimes, I think. Okay, so what we want to do is we want to understand, you know, we sort of saw some choppiness. We want to understand what frames per second we're actually getting out of this thing, and then we want to see how we can kind of trade off the fidelity of our image recognition or image identification with how fast it goes. So to do that, we need to know what our frames per second is. So we are going to create a variable called frames per second report. This is going to be the frames per second that we report, and we're just going to set that to 0. We're just initializing the variable before we use it because we're going to use it in an equation the first time, so it's got to have a value. And then what we are going to come down is, remember how we were making this image bigger or smaller to try to make it run faster? Well, we're going to go ahead and define a variable which we are going to call it scale factor. And we're just going to start with a scale factor of 1. Okay, and let's go ahead and let's fix those places right now that we put the scale factor in. So we're going to multiply by, I think it would be easier if I copied this, so I am going to Control C. And then down here we're going to multiply, instead of by a constant, by scale factor. By scale factor, you see it was 0.25 and I started it at 1 just as a place to start. And then now we are going to, if we multiply by scale factor, then we are going to need to here divide by that same scale factor. Okay. And then also, since we're dividing, that top left, bottom right, it wants an integer, and sometimes you could get a float if you divide, so I'm just going to make these integers just for good measure. And so let's see, I think I'll just copy this whole thing, Control C, then Control V, Control V, Control V, and then this was top, right, and then bottom, and then left. So now I've got one parameter I can change, and I can sort of change that scale factor so we can play around with it. Okay, now back to the goal at hand, which was to, in fact, start calculating our frames per second. Now, if we're going to do that, make sure that you're importing time up here, because we're going to have to use the time function. And then what I'm going to do right here is I'm going to go ahead and get a timestamp. Timestamp is equal to time.time. Now that's the present time in some very goofy type of unit. But that's okay, we're going to subtract 2 of them, and then we should end up with the difference between 2 timestamps should be the change in time between those 2 things. So before we go in this loop, we're going to grab a time. It's like, what time is it before we go in the loop? Does that make sense? Okay, I believe that should make sense. And then let's see, we're going to come on down. We are going to come on down. Okay, now what we want to know is, we want to know, like, right before we do the, right before we do this IM show, what we want to do is right before the IM show, we want to calculate what the frames per second is. So in order to do that, what we need to do is we need to calculate a change in time, dt. How much has time changed between this point and the last point we went through the loop? So we're going to say dt is equal to time dot time, that's the present time, minus time stamp. Well, this first measurement's not going to be perfect because we didn't measure it right here last time. We measured it at the start, but that's okay. You've got to start somewhere. And then what we're going to say is dt is time dot time minus time stamp. And then we're going to say then we're going to say frames per second, FPS, is equal to 1 divided by dt. So if it took 1/10 of a second to go through the loop one time, then how many frames are we processing per second? It would be 1 divided by 0.1, which would be 10, right? If it takes 1/100th of a second to go through the loop once, then how many times could we go through the loop in a second? It would be 1 divided by 100. So we calculate dt, and then 1 over dt should be our frames per second. So that is going to be our frame per second. And let's just print that just to see if this works at this point. So we're going to say print, and we're going to say FPS is, and then we're going to say comma FPS. So we should see something like 10 to 100 frames per second. Now this one, let's see, this one we're actually doing some image recognition. So this one's going to be really slow. And remember, we put this factor at 1. And so the frames per second might be about 1 frame per second. But let's go ahead and run this and see what happens. Okay. Now what you're going to see is, this is just a first look, and there's going to be some things that we're going to want to optimize on this. Now there's way better ways to do this. There's way more sophisticated ways to do it. We could develop interrupts, we could develop timers and stuff, but this is just sort of an easy way to do it that is easy to understand. It's not necessarily the best way, and I can see that I froze up on you guys, so let's come back over here. Okay, there I go. I apologize, but I don't want to start all the way over for a frozen video. Okay. How long had that been frozen? I think that's 2 weeks in a row that that's happened. I'm going to have to be more mindful of that, but I wish I could fix it, but I think it's a USB bandwidth problem. This is a high resolution camera, and it's coming in over USB, and then all my screens and all this other stuff is USB, so it's sort of like my USB just finally kind of vomits on me, and I got to restart it. All right, we should be here running in just a second. The other thing that this is doing is, remember, it is loading that training file, right? It's loading that training file here up front. Okay, let's see. Indeed, a little bit slow today. Let me get this out of the way. And what we will be doing is we will be doing a better, I'll go ahead and tell you what we'll be doing is we'll be doing a better calculation of frame per second, because probably what you are going to see is you are probably going to see a certain amount of noise in this, and we're going to want to try to smooth it out with a low pass filter. I am getting almost to the point of wondering whether I should, okay. Okay, keep waiting. I'm almost wondering if I should reboot the Nano. It seems like an awkwardly long period of time here. Okay, this is going to... We'll give it one more second and then we'll reboot. I'm wondering, I don't think I could have had an error in there that would have caused such a long delay. Okay, here it comes. All right. And this is, remember, we're doing that on the full size. Okay, there it is. So it recognizes me. And let's see. There's my frames per second. Does not appear to be right. Okay, let's look and see what we did wrong here. Oh, I know what we did wrong. Okay, let's quit out of this if we can. And guys, I'm going to change that scale factor back to like 0.5 or something. This is very painful when we're running at full resolution. Okay, I think I will come over here and see if I can kill it ugly with the trash can. Okay, this is the problem, that we didn't reset the timestamp. We didn't reset the timestamp after we did this calculation. So now, after we have calculated and printed frames per second, we need to go in and say timestamp is equal to time.time again. Okay, so now we're grabbing a new timestamp, and then the next time it will be how long it takes to do one loop. And that was the problem, I think. Okay, let's come back up here and let's make this like 0.25 on the scale factor, and at least once it starts running, it'll run a little better. Okay, so now I'm going to come up and let's get this right there. Okay, right mouse click, run Python file in terminal. Do you guys understand? So I take the difference between the present time and timestamp, and then I get a new timestamp, and then when I come back, the time.time will be the now time minus what it was the last time through the loop, and that will measure the amount of time for one loop. Okay, look at that. Boom. All right, and so if I'm sitting here with a scale factor of what was my scale factor, like 4? Is that what I said? My scale factor was 0.25. Yeah, my scale factor was 0.25. And now you can see that I'm getting a frame rate of about 9 frames per second. But you also see it's like 8.99. There's a lot of kind of jumping around in there. So what I want to do is I want to create a low pass filter to kind of smooth that out a little bit. And so I'm going to come on in and I'm going to quit out of that. And so a couple of things, I don't want that many. I don't want that many decimal points. And so I'm going to come in here and I'm going to say FPS is equal to round. I'm going to round FPS to 2 decimal places. And now I should have a simpler one. Okay, and then what I'm going to do is I'm going to build a low pass filter. And so what I'm going to have is that FPS is like the measured frames per second, but it's all over the place. It's changing too much. And so what I'm going to say is the FPS that we report is going to be equal to, I'm going to trust the old report more than the new report because the new report is moving too quickly. So I'm going to put 95% trust in whatever my last FPS report was. And then the new one, I'm just going to trust 0.05 times the one that I just measured. And so if I get a wild reading, it's not going to jump up there. It's just going to move that direction like 5%, but if it stays there, then it will climb on up there. So this is a classic low pass filter. It's going to take some of that noise out of here. And I think on frames per second, I'm going to just go ahead and give it 1 decimal point, okay? And that will make it a little bit neater. And then this FPS report is what I'm going to print, okay? Does that make sense that the new frames per second is mostly the old one, but then I do put a little bit of change from the new reading, and that way you'll always sort of asymptote to what the true value is, but you'll remove the noise. Okay, I think I did a video on low pass filters before. Go look it up if you want to know more about it. Okay, let's say run Python file in terminal. You notice it seemed to that last time load up a little bit quicker. Hopefully we'll get it. Did I run it? What did I do wrong? It doesn't look like it's running. Run Python file in terminal. Okay, now it's running. It seemed like it popped open a little bit quicker that last time. That first time it was really painful. Okay. We got the warning. Let's look for that window to pop open. Okay, boom. And my FPS did not round. Okay, let's see what. Oh, I know what I did. Okay, let's see. Quit. I think I need to. Let me just take this out and let me say print round. I'm going to round just the report after I've done the calculation to 1 decimal point. Okay, and then I need to close that. Does that make sense? I didn't round it there. I am rounding it right when I print it, and I'm rounding it to 1 spot. So let's try that. Okay, what this is going to allow us to do is kind of quantitatively understand what our frame rate is, or an approximation of our frame rate. Okay, so that looks like it's coming up to about 8.7, 8.8. Okay, and you see how using that low pass filter, I've kind of taken the noise out of it. Also, you could see that it's just really stable now at 8.9, right at 9 frames per second, but it took a little while to get there. And so what I think I'm going to do is, it's very stable, but it was a little slow. So I'm going to take 90% of the old one, and I'm going to take 0.1, 10% of the new one. So this will always work perfectly, but it's just this number times the frames per second times this number times the old report. It has to add to 1. Okay, and so I'm going to try to make it a little bit quicker here to get to that value. Low pass filters are really amazing things. You can build a low pass filter mathematically, which we're doing here. Okay, and it's coming on up. All right. And look at that, we came to 9 frames per second, 8.9. Let's see if yeah, it seems like if you do things, you can kind of change that a little bit, like maybe it takes longer to recognize. All right, so that is pretty cool. Now, the one thing though is that I don't want to have to be looking down there in this, in this little terminal window to see that. So I think we can do a little bit better than that. So I'm going to comment this out, all right? And what I want to do is I want to put it on the frame itself. And so what I am going to do then is I am, let's see, after I do all of that, I'm going to put a rectangle on there. So I'm going to say CV2.rectangle. And what I'm going to do, that rectangle is just going to be a small rectangle that's going to be the background for the text so that you'll always be able to see the text. So I'm going to say CV2 rectangle. Where do I want to put the rectangle? I want to put it on the frame, and I want to go from the top left, it's going to be 0, 0, and then I'm going to 0, 0, and then the bottom right, I am going to come over about 100, and I'm going to come down about 40. So that's just going to be a little square, a little rectangle in the upper left, upon which I will put my text. And then let's go ahead and make it red, so it will be 0, 0, 255. And then I want it to be a solid rectangle, so what I will do for the line width is make it -1, and then that will make it a solid rectangle. Let's live dangerously and go ahead and put the text on there. So now I'm going to say CV2.putText, put text, okay, and then I'm going to put it on frame. All right, you guys are seeing this good. I'm going to put it on frame, and then I am going to remember, it wants a string, so I'm going to have to make a string out of what? FPS report. All right, but I don't want to just do FPS report. I want to make it the round of FPS report, comma, to 1 decimal place, like that. Okay, so round FPS report is a floating point number. Round of FPS report then becomes a like 9.1, but it's still a floating point number. And then I have to change it to a string because the put text wants a string. Okay, and then I will go ahead and I will add to that plus the label FPS FPS. So plus is just concatenate, so it takes two strings and it puts them together. So I'm putting the string FPS report and I'm concatenating that with FPS. Okay. And then I've got to give it font, and I think we defined font above already, didn't we? Yes, remember last week we put that font in, and so that should be good to go. And now I need to give it a color, and let's give it the color yellow, which would be 0, 255, 255, right? Yellow is blue, green, red. It's green and red, right? If I'm thinking about this right, green and red should make yellow. And then I'll give it a weight of about 2. And let's see how that looks. Okay, right mouse click, run Python file in terminal. Whoa! What is this? Line 47. Oh, I didn't close my end parenthesis there. Okay. So you see this one has to close this one, I do believe. This should work now, I think. Ooh, integer, it got a tuple. Okay, so let's see. Oh, I didn't give it the position to put it at. So after FPS, I've got to say, where do we want to put it? Well, we want to put it at 0, okay, which would be left and right 0. But then we want to bring it down about 25, so it's not off the screen. We've got to bring it down in Y about 25. Okay, this one I think should work. Have you guys noticed I have more problems with this put text command than anything else? Maybe by the time I get to it, I'm already tired. Okay. I still got a problem, FPS. Okay. Let's see here. It's line 46 again. Must be a real number, not a tuple. So something it is saying is a tuple. Okay, so I've got frame, which is right. I've got string of round of FPS report taken to 1. I close it. And then I add to that frames per second, and then comma 0.25, and then font. I didn't put the weight or the height of the font, so 0.75. Are you guys just screaming at me for? I just don't use the put text command very much, and so that should work now. I really think this is going to work. I'm confident. Okay. Once we get this little ugly put text thing in here, we should start moving along at a fast clip again. Okay, there it is. Boom. All right, look at that. Okay. And look at that. We're running at about 9.6, 9.7 frames per second. That's fairly healthy, fairly respectable frames per second. Okay, so remember that. We're going to call that 9.7 frames per second. And it might be a little tiny bit different than the earlier ones because it might take a little longer to do a put text than to do the print. So that might have slowed us down a little bit just putting that box there. But we'll call it 9.6. Okay, so now if I quit out of that, what if instead of 0.25, let me make it 0.5. Okay, the scale factor of 0.5. Now, if I'm scaling it 0.5 instead of 0.25, do you expect it to run faster or slower? Do you expect it to run faster or slower? Leave me a comment down below. Tell me what you're expecting. Think through this. Understand what we're doing. Okay. So we were at what, 9.6, 9.7 frames per second. Now we're scaling down less. Whoa, failed to, okay. We're scaling down less, and look what happened. We went to like 3 frames per second. So it's like we're 3 times slower. Well, you got to remember that if I go 0.25, it's like this. If I go 0.5, it's twice as big here and twice as big here. So it's really like 4 times as big. So we kind of like almost came down by a factor of 4. And so you can see, now what's the advantage of going to this smaller scale factor? It will recognize me further away. You see how my face can get much smaller and it still recognizes me? Okay, my face gets much smaller and it still recognizes me, so it can find and recognize smaller faces, but it's at a price of a very slow frame rate. Okay, so let's quit out of this. And I think we need to, let's try 0.3, a scale factor of 0.3. See how that does it. But you see, it's kind of interesting. I mean, the point being here, even with those 128 GPU processors, those 128 cores, we're to the point now that we would like higher resolution. Okay, we're at about 7 frames per second, 7.5, and we can do a pretty small face there. Let me turn it over here and see what it looks like. Okay. Okay, that's kind of neat. That is kind of neat. All right, let's see. Let me see over here if I've got any of these old videos up. Let me just call up a quick video here. Remember what we were looking at the other day. A more professional person would have had this queued up already. Okay, let's see. Let's see if this will. Donald Trump, yes. Hey, that's not Paul McWhorter. That's not doing a very good job. Let me see if I can find something else on here, someone more interesting. Let's see if we get him in the middle there, if we'll recognize him. Huh. Let's see. Okay, there it's got him as Mike Pence. I guess it's just thinking all old, grumpy, white-haired men are me. Let's see if I got anybody else interesting. Okay, it's not going to recognize him. Okay, what you can see is that those faces are a little bit too small for it to recognize, and so I would probably need to make something bigger for it to do a better job. Okay, let's see. There's not very many people. I didn't pick a very good one. Let's see. Okay, Dr. Burke, so it got her. Very good. Okay, and you can see that we're doing this at about 7.6 frames per second. When I look at the video screen, you can see that I desire for it to be able to recognize smaller faces, but if we do that, then the frame rate goes to an unacceptable low position, and so that's kind of the trade-offs that we're facing there. But I think this is really neat, and what you guys can do is you guys can go around, and what you can do is you can go around and play with different values and sort of see what you like. Hopefully you guys have training data for members of your family or people in your household, because it's not very much fun doing this face recognition by pointing webcams at videos on YouTube. But that's kind of what we are. That's kind of what we're limited to. Unknown person. Okay, that's kind of what we're limited to here because I don't have any people around, but hopefully you can play with that. Okay, so let's see what I want you to do next week. Your assignment for next week is, and hopefully you guys, hopefully some of you have 2 cameras, and so what we're going to look at next week is running 2 cameras using the Jetson Nano. And so like what I'm going to be doing is a Raspberry Pi camera and a web camera. And hopefully you guys could dig up a web camera or dig up a couple of web cameras or have a Raspberry Pi camera with a web camera. But that's your assignment for next week, is to play around with running 2 cameras And I want you to do it using this frame rate where you have it instrumented with frame rate. And then let's see what happens if we run 2 cameras, and let's see if we can run 2 cameras and get good performance and good behavior. So you can kind of see what we're doing is we're to the point now that we've got to start doing a little bit of optimization, and we just don't have enough raw horsepower to do whatever we want. We're going to have to kind of start optimizing to get things to behave the way that we want them to. Okay, so next week what I want you guys to do is have a program that runs 2 cameras and see what your frame rate is if you are measuring from 2 cameras and displaying from 2 cameras. All right, this is Paul McWhorter from TopTechBoy.com. Want to thank you guys who are helping me out over at Patreon. Again, always remember, you guys, I will talk to you guys next week.